Question number 4 about L'Hopital's rule. First focuses on why can we use L'Hopital's rule. So what we need to do is we basically need to try direct substitution. We plug 0 in anywhere there's an x. So this is like we're plugging it into the numerator. And so let's see what happens when we do that. We get e to the 0 minus 1, but anything to the 0 power is 1. So it looks like the numerator goes to 0, which can be fine, but the problem is we do direct substitution by plugging in 0 into the denominator, and we also get 0. So if you get 0 over 0, that is when you can use L'Hopital's rule. So showing that the limit of the numerator goes to 0 and the limit of the denominator goes to 0, and 0 over 0 is indeterminate form. Now it's okay to use L'Hopital's rule. And L'Hopital's rule simply says that if you want to find this limit and direct substitution gives you indeterminate form, do the same limit, but take the derivative of the numerator. So chain rule, and derivative of -1 would be 0. And make that your new numerator. And then take the derivative of the denominator, which should be 1. And then you try it again. So I'm going to try the limit as x approaches 0 of 3 e to the 3x over the limit as x approaches 0 of 1. So the denominator has nowhere to plug it into, so that just goes to 1. And occasionally you have to use L'Hopital's rule more than once, but I can already tell that I'm not going to have to because this isn't going to be indeterminate form. Our indeterminate forms will be one of these cases. So having a 1 in the denominator tells me that it already works. Go ahead and plug this in up here, do direct substitution. We would get 3 times e to the 3 times 0. Anything to the 0 power is 1, so 3 times 1 is 3. So the limit of that graph as x approaches 0 would be 3. Now, I have no idea what this graph looks like, but you could graph it in your calculator if you wanted to check this answer. Look at the y values, x gets closer to 0, and from the left and from the right, it should be approaching 3 to confirm that that is true.